Hi, and welcome to Introduction to SBOM using software bills of materials for AppSec and compliance. I'm Darren Meyer. I'll be your host, and this is part 2 of the series. In the previous part, we discussed the reason you might be interested in SBOMs in the first place, whether it's for some kind of regulatory compliance, for complying with third-party risk programs, or for general cybersecurity best practices. But today we're going to talk a little bit about what an SBOM actually is. It's unfortunately been a source of confusion for a lot of people because it's been just declared as a requirement by regulators and things without necessarily a lot of definition around it. People who aren't deeply familiar with bills of materials in other sort of industries may not really have something to hang on. Like, what does this mean? What do I actually have to generate when someone says, I need you to generate an SBOM? And really what it comes down to is conceptually relatively simple. A bill of materials is a document that describes all the materials that make up a thing. So for software, it describes all of the materials that make up a software component. Those could be programming libraries, those could be open source frameworks, they could be services and other applications that the application depends on. In software parlance, we call these materials dependencies, right? So this is very similar to something you're almost certainly familiar with, which is the ultimate product bill of materials, the ingredients list. Almost every country in the world has a standard for how ingredients in packaged food have to be listed. So, it always includes, you have to list all the stuff. There are usually some lines about where it all ends, and you have to format it in a certain way, right? This particular ingredients list comes from a package of frozen lasagna produced according to UK standards. And you can see that the ingredients are the things you would expect. It's milk and tomatoes and lasagna sheets and mushrooms and so on. But you'll also notice that there's some interesting formatting choices, right? So things like milk and egg and wheat are highlighted because they're common allergens, right? And so if people are using an SBOM for a particular purpose, like wanting to know what the vulnerabilities are or wanting to know particular packages exist, they want the format to support that. People are reading an ingredients list, they want to know what the allergens are because those are the most important things, right? So standards for SBOMs kind of reflect the same idea. You'll also notice that it doesn't stop at sort of the direct ingredients. This company bought egg lasagna sheets and manufactured them themselves. So those are the ingredient, but those are made of something. Those are made of wheat and egg, right? They bought other things, right? They bought wheat flour to add to things, and that has the flour, but also has some vitamins that are added to it, right? So everything has to be listed. You can't just stop at, what did I grab and make this thing out of? And in software parlance, we would call those the direct dependencies. It's not just the dependencies my developers chose to use to make our software out of. They're also the dependencies those developers chose. We call those transitive dependencies in software parlance. So a little aside here, I said software component a couple of times and I didn't define it. And there's a reason for that. It's a little bit tricky. There's not really a truly standardized way that people talk about what a software component is, and there's not really a standard for exactly where the boundaries of an SBOM lie, just that it's a software component. That could be lots of different things. It could be an application. Some people would argue that an application that calls a service, those are two different components. Some people would argue that's all one because it's part of the application. For this course, I'm just going to define it relatively rigorously as a software package. So if I install something or deploy something to production, that's a package. Could be a library, it could be a framework, it could be an application. It's distributed as a single unit so that I can run it. It might depend on other packages that get installed alongside it, right? Those are dependencies. So the software component consists of that package and everything it depends on, okay? So that's where we're going to draw the boundaries. It does make a difference. You can make different decisions about it. It's going to depend a lot on who's going to consume your SBOMs, because if you draw the boundaries too large, you end up having to disclose things you might not want to disclose. If you draw the boundaries too small, the SBOMs that you produce for your consumers might be unmanageable and cause some tension, some friction for them. You don't want that. So you're going to want to put some thought into how you are going to define it for your industry, for your auditors, for your needs. So we also said document a couple of times. What do we mean by document? So there's this sort of concept that SBOMs are representing an inventory. So the SBOM itself formally is the document. Sometimes people fudge a little bit and they talk about it. They use SBOM to talk about the concept of a software inventory as well. But the inventory is you have data in some format, probably a database of some kind, that tells you what components are part of my software. If you've run any kind of SCA tool, you've done any kind of like dependency vulnerability scan, anything like that, you have somewhere a representation of your inventory. You know what's in your software. The SBOM is a formal way to communicate as a document what is in that inventory, right? Now, technically speaking, an SBOM could be an Excel spreadsheet. It could be a Word. I've actually seen it be a Word document. It can be a PDF, right? It can be a handwritten post-it note. Whether that will be acceptable to the people who want to consume SBOMs is a different question, but it could technically be those things. That said, we're usually talking about one of two formats, SPDX, which is an ISO standard, or a slightly more modern OWASP managed standard called CycloneDX. Both of these have variants in exactly what file formats they use, but they're very rigorously defined. So I want to dive into them just a little bit so you can kind of understand the trade-offs when you're making a decision. You can generally convert one into the other, so the decision isn't a final decision, but you definitely want to save yourself that hassle and kind of decide on the standard that you're going to produce and consume for your organization. Again, depends on what your regulators want, what your, who you're communicating with, who the consumers of this data are, right? So these two formats, SPDX is venerable, right? It's been around for a long time. It's been accepted as an ISO standard. It has a rigorous governance process around it. It's internationally acceptable. Those of you who are familiar with kind of data formats in general will recognize when I say any RDF format is acceptable. For the rest of us, think of it as this way. You can send it as XML or JSON and some other things you probably don't care about, right? That's realistic. The interesting thing about SPDX is it's very, very rigorous, but it wasn't originally designed to be an SBOM format. It was originally designed to communicate licensing data. Turns out those have a lot of things in common, right? You need an accurate inventory for that too. But a useful SBOM document usually want more things that kind of like uniquely identify packages and provide some additional metadata that it kind of didn't have with version 1.0. SPDX had to create a version 2.0 to make it a true SBOM. And it's very, very rigorous. Like there's a standard for communicating every piece of data you can imagine about your bill of materials, right? There's also, because it's so comprehensive, which can make it kind of hard to generate, they actually generated an SPDX Lite version that meets the NIST minimum standards. I don't believe the Lite version is part of the ISO standard, but it is kind of like a reduced subset of SPDX that NIST has said, look, this is good enough, and it's a little easier to generate. So if your core thing is to communicate with the federal government, you could do worse than picking SPDX Lite. Okay? CycloneDX is kind of the opposite end of the spectrum, right? It's an OWASP managed standard. It does have governance around it, but that governance is a lot more lightweight. It's a lot more kind of internet standards type process, right? It too has JSON and XML variants, so you can communicate in the file format of your choice. And it was built ground up to be an SBOM, which has some advantages, right? And one of those is that it has robust features for linking components together, being like, this depends on this in this way, right? And for provenance, it'll tell you like where exactly things came from. It allows you to annotate that, which can be very, very useful when you have commercial components, especially. But being able to distinguish between, hey, this is open source and it came from this repository and this project is very, very useful for having a good understanding of, hey, what is this component actually? They also developed a companion doc, which they are in the process of merging into the CycloneDX standard. Right now, it's a separate document called VEX. In the future, in the hopefully near future, VEX data will be allowed to be in the CycloneDX file itself, so you can distribute one file if you want. And what VEX is it allows you to communicate the thing that most people are interested in SBOMs for, which is, do any of these components have known vulnerabilities? And the cool thing about VEX is it kind of was built with the understanding that, of course, you're going to have some. Zero is too hard of a bar for most people to achieve. So it allows you to kind of annotate what your analysis is and say, hey, we have this vulnerability. We're choosing not to fix it. This is why. There's no update available, perhaps. Or perhaps it's, hey, we've done analysis and we've determined that even though this vulnerability exists technically, it's not relevant. We're not actually affected by it, right? There's no reachable path to the code. There's a mitigation in place that prevents it from being exploitable, whatever the case may be, right? So my recommendation, given these kind of trade-offs, is unless you have very specific needs for SPDX and all that additional weight, um, international compliance standards, um, being able to express data in a rigorous way that's not in CycloneDX or those kinds of things, I would recommend going with CycloneDX because it's just easier and a little bit more ubiquitous in terms of modern tools that can import and export it. It's also much easier to convert CycloneDX to SPDX than the other way. You tend to lose data a little bit because SPDX is so rigorous, and CycloneDX isn't designed for all of the things that SPDX is. It's just designed for SBOMs. So hopefully that gives you a general overview of what an SBOM is and your options for the standard. In the next part, we'll be talking a little bit about how you actually use SBOMs, both as a producer, someone who generates SBOMs to provide to other people who are interested in the risk of their third-party software, and how you use it in AppSec as a producer, and how you might consume these things for your own third-party and AppSec or product security programs. Looking forward to it.